In this lesson, we're going to learn about the properties of identity, inverse, and zero. So first one, we'll start with identity. And again, this is going to be a kind of long, wordy definition, so I'm just going to read through all of it, and then I'll come back and explain it all at the end. So, definition, the identity property of addition is that for all x elements of the real numbers, x plus 0 is equal to x. This makes 0 the additive identity. Similarly, the identity property of multiplication is that for all x elements of the real numbers, x multiplied by 1 is equal to x. This makes 1 the multiplicative identity. So again, I'm going to come back and break down all this. So again, this is kind of some more complex mathematics symbol notation. This was something I didn't have a full grasp on until college, but I figured I would introduce it now as it's nothing too complicated. It was just something that I hadn't heard of until college. So this upside down A, that symbol stands for all. That means for all. So for every single x that is an element of the real numbers, and we remember the real numbers was noted by this goofy looking R. The real numbers are the integers, the rationals, and the irrational numbers. So that means for every single integer, rational, and irrational number, x plus 0, that means any number plus 0, is just equal to that number. This makes 0 the additive identity. So what do we mean by additive identity? Well, hopefully everybody knows what the term identity means. It means what you are, who you are, really what it is. So we want to find out what number makes x equal x. Well, its identity, which is x is equal to x, the only number that we can add to x to make x equal x is 0. So because it holds its identity, that makes 0 what is called the additive identity. Again, because x plus 0 is equal to x. X plus this number equals itself. So again, this is kind of an abstract idea, but these concepts do come in handy later on down your mathematics careers. So again, the additive identity is that for all x elements of the real numbers, for every single integer, rational, and irrational number, x plus 0 is equal to x. So 0 is the additive identity. So every single number, for every single number, 0 is the additive identity. For every single number, if you add 0 to it, it will equal itself. So that's what the additive identity is. The multiplicative identity is very similar. Again, for all x elements of the real numbers, this upside down A stands for all, for every single x element of the integers, rational, and irrational numbers, x multiplied by 1 is equal to x. This makes 1 the multiplicative identity. Again, what number when we multiply by x gives us that number? What number gives us its original identity? What holds its identity? Well, the only number is 1. The only number that we can multiply x by to give us x is 1. So like 0 is what is known as the additive identity, 1 is the multiplicative identity, because if we multiply a number by 1, it gives us its original identity. So again, kind of an abstract idea, but for every single number, for every single real number, it has one identity. There's only one additive identity, that is 0. Similarly, for every real number, there's only one multiplicative identity, and that is 1. So again, these are kind of important concepts to understand. 0 is the additive identity, and 1 is the multiplicative identity. So now that we know what the additive and multiplicative identities are, we can introduce the idea of inverse. So again, there's going to be some new notation in here. I'm just going to read straight through and I'll come back and explain it later. So the inverse property of addition states that for all x elements of the real numbers, there exists a negative x such that x plus negative x is equal to 0. We remember that 0 is the additive identity. Similarly, for multiplication, for all x elements of the real numbers, there exists a 1 over x such that x multiplied by 1 over x is equal to 1, the multiplicative identity. I'll come back and break this all down now. So the inverse property. So for addition, again, we know that this upside down A means for all. So for all x elements of this goofy R means real. For all numbers of the real numbers, integers, rational, and irrationals, there exists, again, some more complex symbol notation here. This backwards E stands for the phrase there exists. So we're saying that for every single x, there exists a specific negative x that correlates to that x. So there's only one. There's only one negative x. ST stands for such that, just because mathematicians are lazy, we like to shorten things up where we can. ST just simply stands for such that. So for all x elements of the real numbers, there exists a negative x such that x plus negative x is equal to 0, the additive identity. So why do we want to have a negative x that when add x equals specifically 0? Well, we want it to equal the additive identity. And we remember that the only additive identity is 0. So we're saying that for every single x, there's a specific negative x that gives us the additive identity, which is 0. So, like identity, there's only one single additive identity, but there are unlimited amount of inverses because this negative x is what is known as the inverse of x. And every single x has a different inverse. Say, for example, you have your x is 1. Your inverse of 1 would be negative 1 because 1 plus negative 1 would be equal to the additive identity. Similarly, if you had 2, its additive inverse would be negative 2 because 2 plus a negative 2 is equal to 0. So again, there's only one additive identity, but there is a different additive inverse for every single number. Then similarly for multiplication, for all x elements of the real numbers, there exists a 1 over x such that x multiplied by 1 over x is equal to 1, the multiplicative identity. So again, we want to get to 1 because that is the multiplicative identity. So just like there's a different additive inverse for every number, there's a different multiplicative inverse for every number. Just like the additive inverse is negative x, the multiplicative inverse is 1 over x. So again, we'll just go through a couple of examples here. So what is the additive inverse of 8? The additive inverse of 8 is negative 8 because 8 plus a negative 8 is equal to the additive identity 0. So if you're trying to find the additive identity number, or the inverse, the additive inverse, you have to find what number gets you back to the additive identity. However, if you have 8 and you want to find the multiplicative inverse, that would be 1 over 8, because 8 times 1 over 8 would be equal to 1. So again, every single number has the same additive identity, which is 0. Every single number has the same multiplicative identity, which is 1. But every single number has their own inverse, has their own additional inverse and its own multiplicative inverse. Just like for 7, its additive inverse wouldn't be negative 8, it would be negative 7, because 7 plus negative 7 is equal to 0. And its multiplicative inverse of 7 would be 1 over 7, because 7 multiplied by 1 over 7 is equal to 1. Again, just go through one more time. Every number has the same additive identity, which is 0, but every number has a different additive inverse, that number to the negative. Every number has the same multiplicative identity, which is 1, but every number has its own inverse identity, which is, or inverse multiplicative inverse, which is 1 over 8 in this case. So again, this is kind of an abstract idea, but it's something that will come in handy later on. And then the last thing we're going to talk about is properties of zero, and these are fairly simple ideas that should be kind of intuitive. So 0 multiplied by anything is equal to, well, 0, because think about it, if you have 1 times 0, well, that's just going to equal 0. I can do this for a billion different examples, but anything multiplied by 0 is 0. Just something pretty self-explanatory. Similarly, 0 divided by anything is 0 as well. So if you have 0 and you're dividing it by 1, that's also equal to 0. So again, some fairly understandable concepts. Now the last one is anything divided by 0 is undefined. So this one takes a little bit more explanation. So what we mean divided by 0? Well, let's look at 1 divided by 0. What does that equal? Well, you might just initially think, oh, it equals 0 because there's 0 in there. Well, no, that's not the case. Up here, 0 divided by 1, think of that as saying, okay, we have 0 cookies, and we're trying to divide it up amongst one person. How many cookies does that one person get? Well, they get 0 because there are 0. This would be the same if we had 0 divided by 10. If we had 0 cookies and we're trying to divide them up amongst 10 people, everybody gets 0. However, 1 divided by 0 is different. Say we have 1 cookie, but we're trying to divide it amongst 0 people. Okay, so 1 split up into no groups. That really doesn't make sense because, you're not giving them to anybody, and that doesn't make it 1 because you're, again, not breaking up and giving it to anybody. So this is where the phrase undefined comes from, because we can't really explain what 1 divided by 0 is. So if you ever see 0 at the bottom of the fraction, you automatically know that this is an undefined phrase, or an undefined equation. So let's just go through a couple of examples of these different concepts that we've introduced. So say we have negative 84n plus 72n plus 84n. So if you ever see something like this, and you see you have a number and it's additive inverse, well, you know that that number and its additive inverse, because it's the additive inverse, those add together equals 0, so you can essentially just cross those out. Our answer is just simply 72n. So again, this is a fairly simple concept. I'm not just going to sit here and bore you to death with it, but again, this is just something very simple. If you have any equation, a number and its additive inverse, then those will just cancel out because its additive inverse equals 0. Another simple example, say we have 0 divided by 3 plus n. Okay, so this might look kind of confusing because we have the 3 plus n at the bottom here, but it doesn't matter what that 3 plus n equals because we have 0 on the top, we automatically have 0. That there could be the most complex thing you could think of. It could be, again, I'm going to pull out some college calculus here. It could be the integral of 3x plus 1 dx. You could have something like that at the bottom of the equation, but you guys will obviously never see anything like this unless you take college level calculus, but I'm just using this as an example. You could have something so incredibly complex at the bottom of a fraction, but if that is dividing 0, oh, the whole thing equals 0. Okay, so nothing too difficult there. Similarly, if you have, say, 10x plus 5 and it's dividing by 0, oh, we have a 0 at the bottom. We automatically know this means undefined. Similarly, it doesn't matter how complex it gets. It could be the integral from -5 to infinity of 4x plus 7x squared dx divided by 0. Again, this will all equal undefined.